Okay, here we are again. Now I want to do a quick, very basic introduction to LEDs because someone did ask me about it on one of my videos. I just wanted to show you what I know about it, which is not much, but I will show you what I know, and hopefully that will help you guys. Alright, so breadboard. If you haven't got one of these, they're very handy. Very cheap. Basically just a piece of plastic you push things into and it joins up in different ways. They call them rails on these, and you can see that this one here, there's two sets of, maybe you can see it, there's two sets of rails going this way, and these are all joined but not together, separate rails. So, I know it's not a very good explanation, but they go vertically this way and there's two of them here. Same on this end. Now across here in this middle bit, these are joined this way, but only up until this big gap here, this big chasm. So these are all joined this way and these are all joined this way. Now that's all you need to know to connect stuff up. If you do buy LEDs, hopefully they'll come with information on what voltage they are, and I guess maybe what amperage you should be using, what milliamps, before you blow them up. Blue LEDs and bright white and the high power LEDs take more voltage, 3 and up. Mine take about 2 volts to sort of crank up. That's what they seem to want to draw anyway. Around about that, we'll go with 2 volts because that's what I'm working with, and that makes life easy for me to calculate stuff. So what we have is we have a 9 volt battery, we have an LED, and we want to power it up. Now LEDs are fairly simple little doodads, and we'll get into that soon. What I want to do is quickly run through some Ohm's law. Now Ohm's law is well, essential. So the way I like to do this and remember it, because I'm a bit simple, is VIR, via, however you want to say it, VIR, voltage, amperage, current, resistance. And draw a big fat triangle. You now have what you need to work stuff out. So what we're going to have in this little circuit, we have voltage, 9 volts, and we have an LED, which we want to run at 20 milliamps. So what we have then is we have the voltage and we have the current that we want. What we want is resistance. That's the resistor we want to use to restrict current through this LED so we don't blow it up. And when I say blow it up, it doesn't actually blow up, it just stops working. Now, the trick with the Ohm's law, there's a couple of tricks that I've found, is you need to make all the values the same. You want to make them all the same unit. Now, I'm not sure if that's the exact term, but what you have is you have voltage. Now current is often written as amperage, amps, or just A. Now what we want is milliamps. Now that's not what amps are. Amps are a lot bigger than milliamp. What I have here, which is something I've downloaded off the net, which has helped me quite a bit, is a little conversion table. Now if I look here at milliamps, you can see it's got a little M. That's the in full. This is the factor, so it's E minus 3. You can use a calculator if you want to, a scientific calculator, and put your E minus 3 onto 20 milliamps and it'll give you an amperage value. But basically minus 3, so easy enough for this one. We will say we got 20 milliamps. Alright, now minus 3, so we'll just say the decimal points here. We go 1, 2, 3, bam, 0.02 of an amp. So what does that leave us is, sorry about that, is we're going to have voltage. Okay. Now the other trick to this is what voltage are we looking at for this? Now we're not looking at 9 volts because that's the entire voltage around the circuit. What we actually want to do is we want to get the voltage drop that's going across the resistor that's in series with the LED. So let's say our voltage is 9 volts and our LED takes 2 volts, so you minus that and you get 7 volts. So that's the drop that's going to be across our resistor. Now 7 volts. Okay, so that's what we want. So we're going to get 7 volts, plug that in, 7 volts, and we're going to, now because this is the trick with the triangle that I use, voltage is over current, so it's voltage divided by current, because that's on top. If we had current and resistance and we want voltage, then you do current times resistance, because they're beside each other. You think of it as like a times. If you know maths, IR is I times R. So I times R gives you voltage. Voltage divided by resistance gives you current. Voltage divided by current gives you resistance. So that's how I remember how Ohm's law works, and that works for me. So I know I got voltage, I got current, I want resistance. Voltage divided by current gives me resistance. So voltage 7. Now I've worked out our amperage, our milliamps to amps. So 7 divided by, sorry about my handwriting, divided by 0.02, which is going to equal, let me get my calculator because I suck at maths. 0.02 equals 350. Now that will be actually ohms, which is nice and simple. If we got 2000 ohms, then it'd be 2k. So it all works out that way. But we have 350 ohms. Okay, so hopefully that's helped a little bit with Ohm's law. We can come back to that later on. Now, so let's do some builderizing.